if you have a binary decimal representation, if you have the digits being RID, you get a physical solution, right? And it turns out if you pick any real number, if you pick almost any real number between 0 and 2, you're going to get the binary decimal digits being RID, right? You have zero probability of actually picking anything that has correlated digits or any dependent digits. If the ith digit is deterministically determined by the previous digits, what happens is you get a periodic repeating of the digits and you get a periodic solution. You can construct what I call quasi-physical solutions if the digits are neither independent identically distributed nor it is deterministically determined by the previous digits, but it depends probabilistically on the previous digits. For example, you can construct a series of digits that has slightly higher than half probability of repeating the previous digit, right? If the 10th digit is 1, then the 11th digit has slightly higher probability than half to be also 1. That introduces slight dependence. And if I compute a long trajectory, I would get something almost equal to the physical uniform distribution, right? If I have exactly 50% probability of repeating the previous digit, I would get IID digits and I would have a physical distribution. However, if I crank up this probability from just a slightly greater than half to 51%, I get this distribution. Now, this is obviously not a physical uniform distribution, right? We know the physical distribution of the tent map is uniform. This is obviously not uniform. Crank it up to 55% probability, I get something significantly different, right? And it turns out this kind of quasi-physical solutions, the solution that is neither periodic nor physical, is exactly achieved by shadowing. So it turns out exactly the same type of distributions is achieved by shadowing under this particular type of perturbation. So you take the tent map, you move the top of the tent map not away from 1 and towards the right hand side, towards 2. And you compute the shadowing solution, right, of this kind of perturbation. If you add this type of perturbation to the flow field, to the tent map, you would get exactly that type of quasi-physical solutions. And compare this with the physical distribution of the perturbed tent map, right? They are dramatically different.
Just clarify this. Sorry, this statement, is it a mathematical theorem or a numerical observation?
Good question. For this particular perturbation, you can prove analytically that once you make this type of perturbation and you compute the shadowing trajectory, you get exactly the type of quasi-physical solutions where each digit has a higher than 50% of probability of repeating the previous digit. And the probability is actually the location of the tip divided by 2. All right. This is I don't have time to go through the proof, but it's actually in manuscript I just put onto archive.